Hello everybody, this is Mr. Lincoln. I am going to be doing 11 through 18 with you on the review. Let's go and get going. I'm going to write this on the top of the page just so that you're aware. If we need to take a fraction to a radical form, then we can do that by doing the following. So make your root, the n, the number on the bottom of the fraction goes on the outside of the root, and the number on the top part of the fraction, the numerator, goes on the inside of the root, and that's the way to go back and forth between these two. So let's do 11a. Keep the parentheses. Always keep the parentheses here. So we have 6x parentheses, and again we need a blue one, so we got a blue 9 on the top, and we're going to be dividing by a red 4. Now we're also going to include this y. This y is raised to the first power, so it's going to be y to the 1/4, y to the blue 1, and then it's still going to be divided by a red 4 because it's all in the root. Next one, let's go ahead and go to the b, and it's going to be 7 is staying, so we have 7 over, and x is going to stay. And by the way, again, we're writing with rational exponents, with fractional exponents. And let's go and do a blue 6 because that's the number on the inside. Number on the outside is a red 5. And there you go. Now I want to bring your attention to one more thing. If you have 1 over something to a number, that's the same thing as something to a negative number. And vice versa. So we could actually rewrite this as 7x to the negative 6 over 5. Either answer would be fine here, and check with the teacher with which one that they would prefer. Because maybe there's a teacher that prefers one method over the other. Okay, so for letter C, the 1 is staying on the top. Keep your parentheses, and we have 28x. And now we're going to need a blue 7, so 7. And then we need a red 3, so we're dividing that by 3. Or you could rewrite this as equals 28x in parentheses again to the negative 7 over 3. Again, either answer is going to be just fine. Okay, let's go on to B. I'm going to drag this down here so that way we have it. No, that's not what I want. There we go. And it's going to go there, and it's going to do that, and that. Oh, not that, not that, not that. Okay, it's going to, nope, not that again. Okay, and great. So if you're waiting on me, give me just a minute because I'll be almost done here in a second. Okay, so we'll need this for 12a. Now we have to write them as radicals, or rational exponents as radicals. So let's set up our root. We have an x on the inside, and then we have a blue 5 because that's the top, and then we have a red 2. Now the red 2 is optional here because when you put a square root, you usually don't put that number inside the tail of the root. Up to you. Either answer would be fine. Either root x to the 5th or the square root of x to the 5th would be fine. For B, alright, so let's go and do this. Let's go and set up our root. Let's go and put the parentheses because they're there for a reason with a 5y. And we can put here a negative 3. And then on the outside we put that 4. And then a different way of writing that again is equal to 1 over the 4th root of 5y to the 3rd. Either answer would be fine there. For the last one, for C, but again, check with the teacher which one is better. For C, it looks like we're going to change 5 to the 4/3. So 5, here's my root. I'm going to need a red 3, and I'm going to need a blue 4 on the inside. That's the first part. For the second part, the x part, well, we're going to need times x to the, let's set up a root again, We got a red 4, that's at the bottom. And we have a blue -3. Okay, so that's one answer. A different way of writing this, and I'm going to erase this part now just so I have a little bit more room and keeping it a little bit cleaner, mostly, is keeping everything at the top here, cube root of 5 to the 4th, but now divided by, because of the negative exponent here, the 4th root of x to the 3rd. Again, either answer would be fine in my class. Please check with your teacher as to which one they're looking for. Now we're on to number 13. Number 13 says to evaluate 16 to the 3 halves. This is your Powerful Numbers booklet where you're looking for a number multiplied by itself twice because of this twice. It's the same number both times, and I believe that is going to be 4. Now the blue number on the top says that I need 3 of those, so I have 4 times 4 times 4, which I believe is equal to 16 times 4, 64. You could type that into your calculator, but again, you have the Powerful Numbers booklet, and that's how you would use it in this problem. 14a. So now we have to write a rule for g. Oh, okay, I got this. So for 14, remember this is a square root function. A square root function starts out at 0, 0, and then 1, 1, and then 4, 2. And it looks like everything shifted a little bit to the left. So this is left 3 units. So our new function then is going to be the square root of x, and if I want to go left 3, I have to go plus 3. Okay, and that's your answer for that one. For b, usually I have 1, 1, and this is up by 2s it looks like, so I'll erase that. Oh, jeez. So, at about 1, 1 and 1, -1 is where the graph usually crosses through. And again, it looks something like that. But this one looks like it grew more. It looks like it got a little bit higher. It does not look like it moved left, right, up, or down. The reason I know that is because of my origin. The origin stayed there, which is right in the middle of that S, which means that the graph did not move left, right, up, or down. Did not move left, right, up, or down. Okay, that's good to know. So that means that if it did not move left, right, up, or down, there must have had been a vertical transformation, which means that we took the y value and multiplied by something. Originally, we have at 1, 1, and we have at -1, -1. Those are 2 points that are on this graph. Our new points are 1, 4, and -1, 4. -1, -4. And what I'm looking at is I'm looking at this -1 and this -4. I'm looking at this one and that 4. And I'm thinking to myself, hey, those are 4 times as big. So then my answer must be the 4 times the cube root of x. Okay, last one. Last one's kind of a doozy one for number 14. Usually my graph of square root is going to look something like this, where I have 0, 0, 1, 1, and 4, 2. That's what my graph usually looks like. So I'll make a little table here. Usually we have 0, 0, so for the original, there's a few points that are on there. One of them is 0, 0. Sorry, I'm cleaning this up. This was from earlier. So I need to put a few points for the original. One was 0, 0. Another one I saw on there was 1, 1. Another one I saw on there was 4, 2. And what I'm comparing them to is I'm comparing them to these green points, 0, -2, 1, 1, and 4, 4. So how do I get these to be the same? So 0, -2, 1, 1, and 4, 4. Okay, and really, I'm not looking at the x values because the x values seem to line up for what I need. I have a 0, 1, a 0, a 1, a 1, and a 4, and a 4. So it doesn't look like there was any changes in x left to right. But I do want to look at these green values, though, and see how I can make them do what they're supposed to. So here's what I'm going to do. I know the graph shifted down 2 because that's how I got this negative 2 there. So I'm going to say 0 times something minus 2 equals negative 2. I'm also going to say that 0 times, or 1 rather, 1 times a y value minus 2 equals 1. And then I'm also going to say the last one here with the 2. 2 times something minus 2 equals 4. Let me just solve each one of these and see what I get. So if I add the 2 here, and I add the 2 here, I got 1 times something equals 3, which means that value has to be 3. If I repeat here, I get 2 times something equals 6, which means that something has to be 3. And if I check, 3 has to be for all of those, which means my answer is going to be 3 square root x minus 2. Tough problem. If I remember correctly, you won't have one like that on the test. Let's go into 15. To rationalize the denominator, I saw a lot of interesting things in my class about rationalizing the denominator. If you don't have any other number there and it's just the root by itself, keep it simple and just multiply by the root by itself. That will get rid of the root for you. So what we'll get here on the top is we'll get 6 root 3. On the bottom it's root 3 times root 3. And that's going to just be 3, or you could do root 3 times root 3 is equal to root 9, and the square root of 9 is equal to 3. So either one of those will be fine. For B, you need to do a conjugate, so let me just clear this off here. Okay, so now let's go ahead and multiply by the conjugate. The reason we need a conjugate is because we have a number and a root, so we have 2 terms instead of just the one term and the other one. So we'll keep a negative 2, but now we're going to do a minus root 5. And I just want to point out, because I saw mistakes in this in my class, you keep the signs of each one of these, you keep the number of each one of these, and you only change the sign. So that's for the conjugate, negative 2 minus root 5, top and bottom, with parentheses. And now let's go and keep going. On the bottom, we have negative 2 times negative 2, which is a 4. We have plus 2 root 5. And then we have minus 2 root 5. Which means those cancel. And then we have negative root 5 times root 5, which is negative 5. On the top, we can go and distribute our 4. When we distribute our 4, we're going to get 4 times negative 2, which is negative 8. And we'll also get 4 times negative 5, which is going to be minus 4 root 5. So final answer, we'll get negative 8 minus 4 root 5 over negative 1. Or if you want, you can just do a plus 4 root 5. Again, either of those answers answer the question, which was basically get the root out the denominator, which is what we did. And then let's go on to page 16. Okay, graph the following functions. Alright, this plus 3 is going to be left 3. This minus 5 is going to be down 5. And keep in mind, the plots I'm always pointing are 0, 0 for a root, for a square root, 1, 1, and 4, 2. So for my first point, 0, 0, I'm going at left 3 and down 5, which is going to start me off at negative 3, negative 5. For 1, 1, I'm going to go ahead and go at 1, 1, I'm going to go left 3, 1, 2, 3, and down 5, which puts me at negative 1, 4. Okay. Now, if you didn't want to do all this, you could have definitely gone to a table, graph this on your calculator, go to the table, plot some points, and you'd be able to do the same thing. For 4-2, so 4-2 starts up here, but I gotta go left 3 and down 5. So left 3 is at 1, down 5 is -3, which means your graph should look something like this. Your domain, remember domain is smallest x value, so domain is small x to large X, and we only put parentheses if we are not at the point. If the point's not on the function, we put brackets if the point is on a function. So I'll just jot that down here for a second. Parentheses, use that for not on function, not a point on the function. And then for this one, for any brackets, when point is on function. Okay, so we got a point here. That looks like it's the smallest x value, which is -3. And I have my class do this. This goes up to positive infinity on x. This goes to positive infinity for y. This goes to negative infinity for x. This goes, that direction goes negative infinity for y. So the domain is going to be the smallest number is -3, but the largest number looks like it's over here, which is going to be positive infinity. So your domain is -3 to infinity. And we do need brackets around -3 because a point actually exists there. As for the range is the smallest y value. So for the range, you have smallest y value to the large y value. So the smallest y value looks like it's about -6. So we're going to go and do -6 then is for the range. And then the graph seems like it keeps going up, which means that infinity will be your other half. And then for B, we haven't really practiced this that much. There's a negative x here. The negative x reflects the graph around the y-axis. The 1 moves it up. Let me just jot these points down again. These are on my original function, the square root of x. And this time I'm going to move it again. Now what I'm going to do is I'm going to switch the signs of these. So that's for the negative part. And I switch the signs of my x's, so I get 0, I get -1, and I get -4. For the y values, it looks like I have to multiply by 2 for each one of these, then add 1. So let's multiply by 2, which is 0, and then add the 1, which is 1, so 0, 1. That's going to take care of this one. I have a 1 right now. If I do 1 times the 2 and then plus 1, that's going to be 3. And for 2, well, 2 is going to be multiplied by 2, which is 4, and then plus 1, which is 5. Okay, now let's plot these. So I got 0, 1, and then I had -1, 3. I kind of just went ahead of you there, and then I have -4, 5. Okay, now let's do the domain. Domain is smallest x value to largest x value. The smallest x value is always on the left, and the left has negative infinity, and then stops at 0. So we have negative infinity to 0. Close on the points, open on infinity. And I'm also going to clean this up a little bit because it looks like my graph starts at 0, 0, but it does not. Okay, next, the range is going to be the smallest y value to the biggest y value. So my smallest y value possible is a 1, and my biggest possible y value goes up to positive infinity. So my range is 1 to infinity. And those are my answers there, along with the graph. And now let's go to the last one. The second to last one. At the circus, the length of time it takes for a trapeze artist to complete one full walk is given by that equation. Where L is the length of feet, the table below shows the lengths of the lines. How long will each walk take? Okay, let's see what we got here. So it looks like I can just plug in L. So remember, walk length is L. So I could do on my calculator 2.31 times 60 to the 1/2. Or if you don't want to type that in like that, you could do 2.31 times the square root of 60. That's for the first one. The second one is 2.31 times 40 to the 1/2. And I'll get the calculator in a second. And again, you could do 2.31 times the square root of 40. And then let's repeat for 100. Now these last ones, and this one I can actually do in my head. 100 to 1/2, or that's equal to 2.31 times the square root of 100. But the square root of 100 is 10, which means that this is going to be 23.1 seconds. Okay? And then repeat for 300. So let's just see what we got here. Calculator 2.31 times square root of 60. And that is 17.89. Here. For the next one, 14.6. So 14.6. It says your answer sitting there is 10, so I gotta actually change my top one. 17.9. So that way it's the biggest 10. And for the last one, I'll do the same thing, but with the 300. So 2.31 times square root of 300, and that's 40.0. So 40.0 for this one. Okay. That's it for those. And now for the final one, the total number of months m that it takes. Find the inverse of the function. Okay. To find the inverse of the function, you have to switch x and y. And solve for y. Now you'll see that there are no x and y's here, so that's going to be misleading. So instead, just say switch the variables and solve for new variable. So for instance, we have m equals p cubed over 90. Let's first switch the variables where we have p equals m cubed over 90. Now let's solve for m. So solve for m now. So that means we're going to multiply by 90 on both sides. We got 90p equals m cubed. Then we're going to take the cube root of both sides. We have the cube root of 90p equals m. Because remember, when you take the cube root of a cube, all those cancel, you're just left with m. And that's your answer. So the cube root of 90p equals m is your answer for the first one. That's the inverse. Now, how many tennis rackets will be produced in a month? Well, tennis rackets is P. And I have an equation that uses P. But the question is also asking, will be produced in 20 months. So let's see which equation we can use. We want to use a, hold on just a second, I'm thinking here for a minute. And to see how many reduced in 20 months, produced in 20 months, just plug in 20 for m here. And you'll be all get your answer. So let's go and do 20 equals p cubed over 90. And then we'll see how many tennis rackets we have if we solve this. Let's get rid of the fraction by multiplying by 90 on both sides. We got 1800 equals p cubed. And then let's go and take the cube root of p, because that's how we're going to drop the cube. Alright, remember when we do that, all that cancels, but we have to do the same thing to the other side too. So we're just going to do this on the calculator. Okay, so it's going to be 12 brackets total. And I didn't put any extra brackets on there because I can't create an extra bracket if it doesn't exist. My answer is 12.